All right, great. So we can start. Hello, everyone. This is our final deep dive session, and I have mixed feelings. It's great that we made it so far, and then we've been able to go over all these different projects. It's also not so good that it's going to be the last, deep dive, and then we have to end the session, the cohort tomorrow. So I'll have also some logistics and words at the end, so we can keep all those kind of logistical stuff for the end. For now, we can start doing the deep dive of the project and going through it. And then after that, we'll do logistics. And then we'll do a short like thank you and goodbye kind of note. So let's start. First 4 weeks, the focus of the course was on LLMs and text generation. And that's because a lot of the applications that are out these days, like AI-based apps or startups, are mostly based on text generation. But there is also a different domain, which is image and video generation. And a lot of companies which are more focused on creative work and, like images, videos. So they heavily rely on those kind of techniques, not text generation. And one obvious example is like Adobe. I mean, it's not only Adobe, but most companies like Canva and all other like startups that are focused on some sort of offering like creative services, they are mostly focused on a different set of techniques, which we covered in last week. Now, the project is also something very similar, to build a multimodal generation agent. And while the name says multimodal generation agent, it's more focused on image and video generation at its core. So the main learning of this project is image and video generation. And basically, we would reinforce the topics that we learned in the lecture. And I have the lecture open here. So a quick review. In the lecture, we first discussed various techniques, VAEs, GANs. Those are older techniques for generating images. And then finally, we switched to diffusion models, which is the state of the art. And these days, they're also like some companies are also using some hybrid techniques. But let's assume that diffusion models are what give us the highest quality image and videos. And then text to image, which just adds the text so that we can influence the image generation. And then we went over all different architectures, including UNet, DIT, how to build this neural network, what is forward, backward pass, and then diffusion process, also forward and backward diffusion process, and sampling, like diffusion sampling. So these are more like concepts and foundations that we've covered in the lecture. When it comes to the code and like applied kind of focus, then you typically do not need to focus. You don't need to take care of some details. For example, units are rarely used these days. The industry switched to DIT architecture. So, and DIT is just a transformer based. So now the underlying architecture is transformer. And even for that, we don't need to, we saw also in previous projects, like there are a lot of type libraries and tools for abstraction. So we don't necessarily need to go and implement DIT architecture. If we search DIT architecture or transformer based, you would see a lot of different like implementation. So we don't need to implement this. So what we focus on in the project is to use some pre-trained model, load it, and then see how this text to image generation works. And in particular, we want to better understand the sampling process. And also a quick review of sampling process in diffusion models. After we train a diffusion model, the sampling process is the process where we start from a pure noise. And the way that this model was trained was to iteratively denoise the input image. So we start from this, we pass it to the model, which we would load in our project. And then the model would predict the noise. And then if we subtract that noise from the input, we would get a more clear image or less noisy image. And this is an iterative process. So in practice, in the original paper of DDPM, it was suggesting to do 1,000 steps to go from pure noise to this clear image. But then over time, there were a lot of effort on efficiency because it was taking very long time to generate one single image. So then there was this DDIM paper where it suggested to make certain changes, and then instead we can make it work in 50 steps only. And then there was also more work on making those steps less and less. So this is what we would see mostly in the project. We go from this noise, and then this whole thing is also implemented. So we don't, like, similar to LLMs and text generation, where we don't have to implement the top P or top K sampling. There was just this loop, and then Hugging Face was already giving us the implementation. It's the same process. In practice, when we want to implement or we want to build a text to image or text to video model, most of these functionalities are already given or provided. So this is just a quick overview. So the project starts with building a text to image and just playing around with some hyperparameters to see what makes difference and how it makes difference. And then after that, we do the same for the video. And then finally, at the very end, we put together everything we learned. And we also add a router, which can be a lightweight LLM, to make it a multimodal generation agent, where you can just ask it anything. And if your request is just a text-based request, it would answer text. If it's an image generation request, it would generate an image. And if it's a video generation request, it would generate video. And that's very similar to a ChatGPT. If I ask, hi, how are you? How are you? It would output text, because my question type, the nature of my question requires just a textual output. But if I say, generate an image of a dog, then it would be different. The UI is different. So what is happening under the hood, there is some mechanism or some model that determines that this request is an image generation request. And then it no longer sends it to the same model, same GPT-5 model. It now sends it to an image model. I think for OpenAI is GPT image or something like that, or I don't know what they're doing under the hood. But one of their latest image models that they introduced was their GPT image. But anyway, we would just try to build something like this. I don't know if it works for videos or not. I think it would not. I'm not sure if I asked to generate a video, it would generate a video using Sora model. Let me try. Generate a video of a dog. I can't directly generate or render videos. There is definitely some reasoning behind it, but yeah, what we would build is capable of doing this. It's just a simplified version, but it would be capable of doing that. All right, so now we can go to the project. I downloaded this project and I opened it on Cursor here. And then we are going to run it on Google Colab, because image generation and video generation models are more intense and requires more computation. So it's typically require GPUs, good models out there, and powerful GPUs. And so in this case, I prefer just to rely on Google Colab so we can use their GPU. And one more thing to note before we start, as we move forward in this project, there might be cases where I implement something simpler, and then we try to run it, and then we run into efficiency issues, and then we go back and fix things or try to make it more efficient. So that's intentional. So I have opened this Colab, and it's already here. And so yeah, now I guess we can start doing the projects step by step. So the first part is text to image. The environment setup. In this case, we are relying on some pre-trained text to image and text to video models. They are provided by Hugging Face. So if I search text to image models, Hugging Face, it would probably give me a list of possible models out there which I can use. So it might be an interesting practice if you're curious to go read some of these and try. Some of these, like Flux, are really, really good, especially the newer versions. Some of these, I think this is pretty recent. And Qwen, as always, their models are awesome. And then the Stable Diffusion. So all these are interesting models, and some of those are very unique. So if you're interested, it's typically a good practice to try some of these. But basically, what all of these are offering is, let's say, Qwen. If you click on them, you can use this model. And then basically, it shows you how to use it. It shows you the instruction and the model ID to use. So some of these models require you to log in. And then for logging in into Hugging Face, you require a token. So I'm going to do the token here. just so we go over it live. So here we can click access tokens and then my password. And then here I have a bunch of already from before some tokens. You can create a new token or you can decide to refresh some of this. I think I can refresh this one. And then it would give me a new token. I'm copying it and pasting it here. So now this should allow me to download whatever models that require Hugging Face login to work, and I can download them. So let me run this cell. Great. And now let's also import these libraries to make sure that we have all the dependencies that we need. Since we are on Google Colab, we already have the dependencies most likely. So it would just run. But the libraries that we are importing here is one is Torch, which is for our like Torch related like basic stuff. Transformers is the Hugging Face transformer. We saw it in previous projects. It's mostly for to load the LLM, and we'll see why we need LLM. That's for routing purposes. OS random GC are just minor things, and diffuser is basically image and video generation version of transformers offered by Hugging Face. So with diffusers, you can just load models and use them. All right, so it seems we are good. The CUDA true, so we are on GPU. So GPU is available and Torch is good, and it's a CUDA version. One more thing I want to make sure is that I select the right runtime. So I want to use GPU or TPU, not CPU. So change runtime type. So it's already on T4 GPU, which is good. Great. So we are set up. We'll go to the text to image. There are, again, lots of different text to image models that you can use. In this case, we are going to rely on what is suggested here, Stable Diffusion XL. So I have already this here. So this is a Stability AI, a Stable Diffusion XL base 1. This is just the model ID. We use it to load the model. And then, so the rest, I'll just implement them. They are very, again, the autocomplete. All right, that's probably fine. So you can do pipeline. So previously for text, we used to do pipeline text or just pipeline object. So here I'm going to do pipe image and then diffusion pipeline, which we imported here. This is used to load pre-trained pipelines, image generation pipelines. And then dot from pre-trained. So this is very similar to how we used to do it for text from pre-trained. So a couple of things we need to pass, model ID. Let's keep it like that. And all right, so this is going to load the model. Now, if we load the model, it's going to take quite some time because by default, it's going to be on CPU. So I'm going to move this loaded model to CUDA, which is the GPU that is available on Google Colab. You can also say if torch.cuda.is available else CPU. So here we are just moving the loaded pre-trained model into GPU if available. So now let me run this. It would else CPU. It may take a while because some of these models, they do have billions of parameters and just loading them is several gigabytes and it takes time. So in this project, we would have a little bit of overhead while these models are being downloaded. So in the meantime, I would just go to the next cell and go over the implementation, and then we'll come back. By that time, it should be ready. But you can see there are a bunch of things that the pipeline is downloading. So one is the text encoder. This is important because we saw in the lecture that in text to image models, after training your model, there is this text encoder part. So that's part of it. That's basically a way so you can influence the generation with your description. You provide the description goes to a text encoder, which is usually trained separately. And then the output of this text encoder would be just a sequence of, like, let's say, sequence of vectors. And then those sequence of vectors, along with the pure noise, goes into the diffusion model. And this is how the generation works. So going back here, so that's why it's downloading the text encoder. This is what text encoder is. Also tokenizer for the text encoder. What else? Some configs for the model, like which specify the hyperparameters of this stable diffusion model. And then a bunch of other things like the actual safe tensors, like the actual weights of the model that is being downloaded. And those are usually like 10 gigabytes of storage needed. So while this is being downloaded, let's go here and let's implement this. So here, now we downloaded the model. It's already pre-trained, meaning that the weights are already adjusted to correctly generate images when you provide a textual description. So let's create a prompt here, cinematic. I will use the same examples that we have in the solution that we would release, so we keep things consistent. Future tick. Neon cityscape at dusk. So for this prompt, I used ChatGPT to give me a prompt, just a random prompt. So this is where it's coming from if you're curious. So we have this prompt. Now, the rest is very simple. Hugging Face already abstracted away all those loops and iterations and denoising and subtracting the noise and like passing the input to the model, subtracting the noise and then getting a denoised version of the image, again passing it to the model and so on. So this loop is already this loop here, it's already available by Hugging Face. So we don't need to implement it. If in future you are interested to learn how to implement this, you can go and take a look at the implementation of the diffusion pipeline, and you would see the loop. It's very simple. So to use this, we can say pipe image and simply pass the prompt. And then since it outputs different things, and then it may expect the batches. So here we also take the do dot image as 0 to get the image. Great. So now we have this, and then I print image to see what the output is. So let's see where we are. Okay, we are halfway through here, and then it may not also work. That's the so that's because this is not the most efficient way to load this model. Let me figure out a better way to make this faster. Okay, perhaps we can just continue while that is being downloaded. So or maybe we'll wait. So in the meantime, I can explain this part. What is going to happen here is that when we call pipe image and send this prompt, under the hood, the prompt goes into the text encoder. The text encoder produces a sequence of vectors. The sequence of vectors, along with the model, they go into a loop. It starts with a pure random noise, and then at each step, it denoises this image. So the image becomes clearer and clearer, and it becomes more similar to this sentence. Now, there are a fixed set of steps that this loop continues. And it also depends on how the model was trained. There was this DDPM paper. DDPM, if you are interested, you can read it. It's basically the paper that introduced the text like diffusion model with generated images with a reasonable quality. So this paper, based on all the theories and mathematical details, it was suggesting 1,000 steps, I think. Yes. So they set 1,000 steps for the denoising process. And then later there was this DDIM paper when it just changes the inference time process to go from 1,000 denoising steps into 50 steps. So it's typically much faster and more efficient. So again, if you're interested, there are lots of theories and details. But if we search 50, so you see these are like different number of steps where they go over the denoising process. And they're showing that 50 is a reasonable number of iterations based on the error. And obviously, if you do more denoising process, the error would be less, meaning that the images would be clearer. But there is a trade-off between the quality of the generated content and the cost and time. So let's go back here. Okay, this is downloaded. Let me run this. I think again, we have to wait. So the 50 that you are seeing here are the number of iterations. It's the same thing. So under the hood, by default, this pipe image is relying on DDIM, not DDPM, and the default value is 50. We can easily change it to smaller or larger numbers to see how it changes. So while it's running, this is basically the experiment for 2.3, experimenting with different inference steps. And again, what you should expect is that as you increase the number of steps, you should see higher quality images. And as you decrease the number of steps, you would see less quality images, but images are going to be generated faster. So what we are going to do here is we are going to experiment with this. 10, 25, and 50 are three different thresholds that we would use to see how the quality would be different. So, and then this part is just plotting, so it's already provided, so I only need to implement the core part. So for the prompt, let me use the exact same prompt here. So we have the prompt. Now let's also create a list of a steps list. Just to be faster for the purpose of live session, I'll set a smaller values. So I'll set 5, 15, and 30. But in practice, you can try different things. And I think that's the purpose of this step, visualizing the diffusion process with all different steps. So we are not going to do this. It's going to take time. But the logic of implementation is going to be exactly similar to this. Just this steps list can be all values from 0 to 50. All right, so we have 3 steps that we are interested to see how it would look like. I'll go over each steps. I would generate the image. Inference steps, it is what Hugging Face Diffuser is providing us to control the number of inference steps or denoising steps. So for this, we'll set it to steps. And then, so there is this guidance scale. I'm not going to go too deep into this. If you are interested, I would suggest to read the DALL-E 2 paper, I think, or I don't know if this is the same paper or not. So I suggest you first take a look at this classifier-free diffusion guidance, and then you would get a sense of what the guidance means. So I'm not going to cover that. All right, so there was an error, and that was expected. We are seeing CUDA out of memory, and then it's because these models are big, and the free GPUs are not too powerful. So just loading the model this way won't work. So I'll go back and I'll make it more efficient. So when we say from pre-trained, there are other things that we can specify. One thing that we can specify is the D type. Let me go over what D type is. By default, neural network models, including LLMs and diffusion models, are saved with float 32, meaning that each weight or each parameter of this neural network has 4 bytes. Now, one way to keep these things more efficient, we can just load them and ask PyTorch, or in this case, just Hugging Face takes care of it, to set the type to something more efficient. So in this case, we can set it to float 16, which only requires 2 bytes per parameters. So this way, if the model required, let's say, like, I don't know, like 20 gigabytes of memory to be loaded, but by just this simple change, it now requires almost half of that. So 10 GB, let's say. And that makes a big difference because the best GPUs out there, like H100, they have like 80 gigabytes of memory. And then we need some buffer in the memory to be available for the generation process. So it's always good to save that. So save that memory for generation. So this simple change can make a big difference. So that's basically the main thing that we needed to do here. If you're interested, you can search this variant. I'm not covering it here, but these are just minor things. The key thing is just to load it in lower precision type. So I hope that if I run it again, it would not. I don't know what's going to happen. I don't know if it has to download the whole thing or not. Oh, and one more thing before I do this. So that's one way that we can make this thing more efficient. The other thing is, after this is loaded, there is this attention mechanism. So we already discussed attention. And attention is typically not efficient because it's not efficient because it grows. It grows with the sequence length. So it's a square, like S square, the time complexity of it as the sequence length increases. And in images and videos, we saw in the lecture that the first step is to convert the image or video into a sequence of vectors. And that's because we want to keep it and make it proper for transformer to process it. And in high resolution images or videos or models that are trained with high resolution images and videos, this sequence is going to be very long. So since the sequence is long, computing the attention scores within the DIT model is going to take a lot of time and requires a lot of memory. So attention is typically the bottleneck. There has been a lot of work, a lot of efforts on making attention more efficient. And one really good paper that in practice many companies are relying on is Flash Attention paper. And right now they have Flash Attention 3, I think. Or maybe there are also more recent versions. So this paper, if you are interested, you can take a look. It's very difficult if you don't have a hardware background. I don't also understand it fully. But they go into the very lower levels of like they rely on a lot of characteristics of how the GPUs are designed and how these things work, and then they use that to make the attention more efficient. So this is one example. There are other variants of making attention linear, its time complexity, for like in terms of memory that is needed. So these are only read it if you are really interested to know the low levels and how GPUs work. But in practice, we almost always need to rely on those efficient versions of attention, both when we are training and when we are using the model. Otherwise, these models would be quite expensive and it's not even possible to load them. And that's why a lot of startups or companies that are offering to generate images or videos, especially for videos, the length of the video is limited. So initially it was like 2 seconds and then it was 5 seconds. And even these days, I don't think there is any company that can generate images natively using the foundation model over like 10 seconds or something. That's mostly because the attention is the bottleneck. And also these models, they're big enough and the memory of the GPU is limited. So one thing that I'm going to do here is to enable the attention slicing. If you are interested, I'm not going to go over this. Like the high level I covered, it's all about making attention more efficient. So now with these two lines, things should be more efficient, I hope. Let me rerun this. Okay, since it's going to do it from the start, just to make sure we are safe, I'm going to restart the session just in case the memory is not empty. So let me run this again. Import. All right, and then now I'm going to run this. Great. So it's going to just run and download the model and move it to GPU and make sure that the parameters are lower precision. And then it would enable the attention slicing. So while it's being run, after it runs, I would run this again with the same set of inference steps, 50. And then we'll see if it works or not and what the image look like. But what we should expect is that first, it should work, meaning that we should not see CUDA out of memory error. And second, it should be faster. So let's see if that's going to be the case. I'm going to move forward while that's being run and going through this implementation. So we set these 3 steps, and then we went through them, and then we generate the image using the very similar code as before. But the only different thing is that we now set the num inference steps, and we set it to steps. And these are these keep changing with newer versions and depending on what tool you are using. So the best way to figure this out is just search the documentations. Like something like this, and then it would just probably show you how to use pipelines. So if I search, so you would see that this is how it's being used. So these kind of documentations are typically very useful before implementing any text-to-image or video generation models. So yeah, just wanted to share that these things keep being changed, and I don't even memorize most of these things. As long as you know what you are looking for, it can be found online with some searches. Great. So this is done. We are we have the images, and now I need to create a list of images here. Oh, it's already here. Now we need to append. So we'll append all these generated images into the image. So we keep a list of images. And once we have that, oh, my session crashed, unfortunately, after using all available RAM. I don't know what happened. The best way is to rerun it again. In practice, in companies, these things are not going to happen because you typically have access to good, powerful GPUs. All right, this is also good. And by the way, these things happen a lot. I remember when I was training foundation model in Adobe for text to video generation, I was dealing with this CUDA out of memory like 20% of my time. That was for training, so that's a different story, but still it happens frequently. And then you just need to figure out why it's happening, what is the bottleneck, how can it be um, more, you can make it more efficient and so on. So it's going to be a unfortunate thing. So let me just copy paste what we had. This seems to be loading. I'm going to also put this here. And then our implementation for this step. It's also just a best practice kind of suggestion that I learned is that it's always good to load. So when you're loading the model, which is very time consuming, it's always best to have it in a single cell. So don't even move it to CUDA or whatever. And then all these things can be run in the next cell. So if there is a typo issue, which apparently I had a typo issue, but if there are some problems or something is wrong, I mean, you don't have to wait again to download the model. Um, so in this case, I was not following my own best practice, um, but that's typically a good thing. It helps to prototype faster. All right. So while this is going to take a while to be loaded, as we saw, and then after those two, I'm going to run this. And then this part I already covered, visualizing the diffusion process. It's optional. We are not going to implement it. The implementation is going to be exactly similar to this. Just the difference is that you just need to go over all the steps. So the next cell is text to video. I'm going to pause here. And while this is being run, we can maybe slightly change the format this session and take some questions. For the questions, please keep them technical and relevant to the text to image only. For anything else, we would just cover them at the very end. So only please questions relevant to what we just implemented or if it's related to text to image. Sonia?
Yes, hi Ali. Thank you for the session. So like you said, Hugging Face is hosting all these models. So all these, like we picked one, this stable diffusion Excel. All these are open weight, open source, or whatever is on Hugging
So
Face.
yeah, that's a good question. In general, um, if a tool or library like Hugging Face is allowing you or offering some models, they must be open weight because that's the only way that these tools or libraries can host those models, and then you can download them. As soon as you download them, you have access to the model. Like here, like this pipe image. I mean, this is one way you can download it. But what is happening under the hood here is it's actually downloading the model. So you can go and inspect and look at all the weights, even fine tune them. So typically, whatever you see here is open weight. You can download them and use them. You need to pay attention to their license because some of them are allowing commercial use cases, some may not. So that's a different story. But in terms of just accessing to the model's weight, yes, they must be open weight to be hosted in these places.
Okay, and then we just use like that access token, that may be second step to access them, right?
Yes, and that's more for authentication purposes. Yes, and I think many other APIs or also tools require that. I think even Llama, like Meta Llama, like Llama from Meta, when they released the model, they were also requiring some sort of authentication to go through some forms or something like that. So for all these big models that are certain risks, there is always some kind of authentication required and some like like agreement kind of thing.
I see. Okay, got. So this API key is required for some security reasons, right? Something, even when it is
I,
open
I,
way.
I I think so. We can
Okay.
ask ChatGPT to see if there are
No,
other
no.
reasons. There might be also other reasons, but I feel one important aspect is for big models, they are quite capable. And in general, you need to make sure that you know the policy and require and agree and you like accept the agreements
Okay.
or whatever
Okay.
they are having. Yeah.
Got it. So if you don't mind, like I've read it online, but if you could go a little bit over Torch, just for a few seconds maybe, or whatever time
Um,
you want to give, if it's okay
Torch.
with it. Torch, yeah. Or you
Okay.
want me
But
to do on my own, I can do it if you want to skip it.
um, if it's torch related, if possible, let's keep it for
Okay,
the
okay.
end.
No
Yeah.
worries. No
Yeah.
worries. So, yeah, and then, like we set in runtime, we set it to use the T4 GPU, right? Change runtime, we
Mhm.
did
Yes.
that. And again, then do we still need to write this code that dot to CUDA? I mean, despite of that?
Oh, yes. Yes. We need to do that. And in general, what is going to happen is when you change that runtime, basically it's giving you access to the accelerator. So in general, let's say forget about Colab. Colab, they might also have their own defaults, but this is the general case. You have a machine in your company, and then the machine also offers you a GPU. So you have access. So on your machine, you have access to GPU. And this GPU can be cloud-based or it can be a physical GPU. It doesn't matter. So you have an ID, and then the ID is there is also a GPU available to you. Now, just the fact that there is a GPU, like a Harvard GPU, available to you, it doesn't mean that it's going to be used. So in order to use them, you need to move tensors. And at the end of the day, everything is just a tensor. I mean, we see this pipe image and it's an object. But if you go into the model itself is just a tensor. The input that you send, like this sentence here, it's going to be a set of tensors, right? It's going to go to the tokenizer. The tokenizer output is going to be a sequence of tokens. And then sequence of tokens, they would be represented by just numbers, and they're in a tensor. So everything is going to be tensor. In order to use your accelerator, whether it's GPU, TPU, or anything, you have to explicitly move your tensors to GPU and also move them back from GPU to CPU if for certain use cases you want your computations to happen on CPU. And that's also common in certain data processing workloads. You occasionally want to run things on CPU for different reasons. Um, okay, so this is crashed again. Um,
I think I just used a lower level model. It was just crashing so many times.
Yeah, I think it also depends on sometimes when you load the when you open the Colab, it provides more powerful GPUs. So it also depends on that. In general, I can switch to a smaller model, but um, the first time was better. It loaded the model and it went through the iterations. I think this time it failed when it was downloading the model. It is obviously something related to like just the fact that we are using Colab, it's free version, the GPUs are not good enough, and so on. So I'm going to move forward with the implementation of the video while this time this one is going to be downloaded. Let me make sure that it's restarted. Okay, I really want to show this because it's going to run. I have tested this before the session, so I think it's just the collapsing issue. I really want to show this before I move to the video. So this is going to be one last attempt. If it doesn't work, I would continue to the text to video. And in the meantime, I see there are lots of raised hands, so I can take more questions.
Ali, can I finish? I want to ask a little bit more.
Sure, yeah. Do you have more questions or it's
Yeah.
the same?
No.
I mean,
No.
if that's okay, let me move forward with more questions,
Okay.
and then still I can take more questions at the very end. Yeah, thanks, Sonia. Harpreet?
Hey Ali, so one quick question.
Hey.
So what you are experiencing is pretty natural in a proper ML pipeline, right? You try something, it fails. How do we make sure that we are checkpointing all the steps so that when a new code is deployed, you start from the step where it failed rather than redoing the whole thing, which will cost time, money, uh, everything, right? So what's the best practices where we checkpoint and make sure that we start from the place where it failed?
So I assume you're mostly referring to training time, because at inference
No,
time there
not
is.
even training time. So even
Mhm.
this time where we are actually doing inference for a user, right? A user asks a
Mhm.
question, it runs through a RAG pipeline or any other pipeline that we build or image generation pipeline, and it fails in one of the steps, right? So when we
Mhm.
do a retry or do a code fix, any of the options, so we start from the point where it failed rather than from start step zero.
Okay, there is still one more question I have for you. Are you referring to the, like, from the developer point of view as you are developing the inference code, or you are asking this from the user perspective where we want the user to have a best practices? So when, like, the best experience. So when the user enters something, what are best practices to employ so that they don't see a failure thing? Which one
Let's
you are?
take the second scenario first, where the user is trying to ask a question on a RAG-based application. Some failure happened, and now we recover it. How do we recover from it? And we start from the step where it failed rather from step zero.
It typically doesn't happen in practice. At least I've rarely seen it happen. I mean, as long as you have dedicated GPUs, which companies typically have for this purpose, so they have full GPUs, it's already tested and it's already available, and then everything is already unit tested in a sense that we know that when the user's query comes, we ensure that after it's been converted to a sequence of tokens, we drop if the sequence of tokens is more than a certain length. So all those things are put in place. If that's the case, it rarely happens. It only happens if there is a failure from GPUs, and that can be quite common, like failures, like GPU failures. But in practice, what happens is that there is a fallback mechanism. So when the questions come, when one GPU fails, there is like typically the platform that companies use monitor all these GPUs and how it works and which ones are healthy, which one requires a restart, and then they take care of all these routing the requests. So in case there is a request going into a GPU and the GPU fails for any reason, like the hardware fails, the request would be rerouted to a different GPU, because there is not a single GPU in practice that are serving users' requests at inference time. There are typically like 10 or even hundreds of GPUs that are all dedicated only for inference. Okay, this crashed again. Yeah,
And
does that
how do we
make sense?
do? A little bit. And how do we do it from the developer's point of view when they're developing the inference that they're doing? So,
Mhm.
or
Yeah, I mean,
training.
yeah, it's mostly the things that I just described. For example, from the developer point of view, you need to make sure that you have certain limits. You make sure that, for example, the sequence is not going to ever exceed um, the certain threshold that your model or your system can support. So if the user, let's say, enters something here, like a very big paragraph, you obviously don't want that. It may not work. So those are all the, like, kind of small things you need to make sure that you have as a developer of the application, so that nothing unexpected happens. So that is one example, like which I've seen a lot in production. The users enter something very big, and like a few paragraphs sometimes. And then it goes to the text encoder. The text encoder generates a very long sequence of IDs, and then things would fail. So it's always good to have those kind of simple if statements. If that's the case, some heuristic like drop certain parts of the text or rewrite it, just to make sure to avoid. And beside
And
that, yeah, go ahead.
sorry, yeah. And for training, when there are like 10 steps in the training and we find out there's a bug in, let's say, 6th step, and they fix a bug or fine tune one of the parameters and they want to start from the 6th step, not do the first 5, which would have taken, let's say, 4 days to train.
That can work, but in practice, it's not going to be that slow. I mean, if you see like ChatGPT takes like 10 or 20 seconds, right? So doing that would introduce a lot of complexity if you want to checkpoint the like certain step. It also requires a lot of additional storage, because as you are generating those, you have to just keep checkpoint them, and you need to do this for every different user. And this whole thing is gonna, I mean, in case something fails, it would just save probably a few seconds of users' time. So it's in practice, the complexity is more than the value that it brings. At least I haven't seen like checkpointing at inference time. And a lot of these companies, I don't know about OpenAI, but I know a lot of companies offer text-to-image models. They work a lot on efficiency. So at the end of the day, the model that they end up deploying, it requires even less than 50 steps. It's like less. There are also some works like consistency models, if you are interested to read them. They are suggesting ways to make this number of inference steps to down to 5, 2, or even 1. So also take a look at, and also one of the authors is Ilya. So this is a very interesting work, which suggests how to go from like even 50 or 20 steps to a smaller. Like I think they also have 2 or even 1 steps. And there are a lot of follow-up papers on top of after these consistency models with the same purpose. So long story short, companies typically do not even do 50 steps. They have a more efficient, faster model using different techniques. And then just the checkpointing is just too much complexity. All right, so I guess I'll move forward. This is gonna work. It used to work. I don't know. Even the loading seems to be slightly different now from the first time. Yeah, I don't know. I'm just going to restart this, run it, and go to the text to video section. So yeah, I took a screenshots of what we should have seen. This was expected. So this is for this cell experimenting with inference steps. Let me also show you the actual 50-step image. Is that visible? I assume you can see this big high resolution image. So this is the output that we were expecting to see with 50 steps of denoising. So you can see it's pretty, it's high resolution, and it's also reasonably good quality. All right, so that was the 50th step output that we were expecting to see here. And then for this code, 5, 15, and 30, this is the output. You can see 30 is not as good as 50, and 50 is, and 5 is even worse. Let me also add the 50 here so we can compare. this is 50. And then you can see 30 is not as good as 50. There's some it seems here, like this area does not seem to be too clear. And then it just keeps getting worse and worse. And you see at 5 steps, it's just, it's not acceptable, the quality. So if you also print it at step 1 or 2, it's just pure noise. And then it just keeps getting better and better and better. And as you continue beyond 50, it would probably even be better, but not significantly. So 50 is a good standard in practice that is typically used. All right, so that crashed also. So I'm not gonna even run this next time. So I'm going to just run the video part. I don't know if I switch to this, it would solve the issue or not. So this is what I was referring to. Sometimes by like randomly, Colab just provides more powerful GPUs. So in those cases, probably we can easily run things. Yeah, but for now we can just keep it. So let me run these two and then go to the video part. So whatever we covered for images, it's exactly similar for videos. It's just the model itself was trained for videos. So these days, the best models, even the model architecture is the same. So it's still a DIT, a transformer based model. And then for images, the input image goes into a so let me go here. It goes into a patchification process. So in images, when we are training, the image goes to this patchify process, and then we would end up with a sequence of vectors. The same is true for videos. So that's the only part that is just different between image to text to image and text to video generation models. When it's a video, we have also a third dimension here. But regardless of that, we can still run, we can still divide and flatten, and then we would end up with a sequence of vectors again. And once we get this sequence of vectors, the rest is the same, meaning that the positional encoding, transformer, and unpatchify is going to be very similar. I think there was also maybe a visual here for videos. Yes. So this is the only difference, text to image and text to video. The rest of the training is exactly similar. The training data is different. Instead of images, we have videos, and that's the only difference. And the patchify is also different. But the models the architecture of the model is typically very similar or overlaps a lot. So, and again, same story, Hugging Face also offers video, text to video models. Hugging Face, text to video models. Probably we would see just a collection of different possibilities. So this is the one that we would use, but there will be more models. So yeah, and Cog Video is very good. I've used it before, but it's going to be interesting to try these different models. We are going to start with this model ID and then do something very similar to what we did before. We'll do this time pipe width equal diffusion pipeline dot from pre-trained video model ID. We'll set the type to video model ID. Then we would set the D type to torch.float16. and P16. So this is going to be the code. I'm going to follow the best practice that I suggested here. So I'm going to just load this model. Hopefully it would work, but let's see. And then in the next cell, I would here I would implement the next two lines. So this is too detailed, so I'm not gonna explain it, but I'm going to just provide a high-level overview. So these models, diffusion models, both image diffusion models and video diffusion models, there is this thing called a scheduler. And a scheduler just refers to these inference steps. So how to go from pure noise to the clean version, and what are the time steps that we should jump to at each step. So for example, one scheduler may just uniformly go down from time step 0 to 1000, let's say, if we want to do 1000. Some may go with a different schedule. They go from 1000 to 900, from 900 to 700. So they introduce this jump up, this concept of jumping from one time step to another. So this is too detailed, so I'm not going to cover it here. But if you're interested and if you search for schedulers, you would see like what are different schedulers, how they work, and so on. So that's it. So I'm going to copy paste. Okay, the session. Okay, I think that was from before. Okay, it loaded. So these two lines are just setting up, loading the config of the scheduler that this model was trained on. And then we also just some efficiency work. So let me run this. Okay, this was fast. And then the next part is just generating video, very similar to images. So here, let's say we have a prompt like astronaut walking on Mars at sunrise. I obtained this from ChatGPT. And then it's just the same as before. We send the prompt and num frames, like desired num frames. I set it to 16. And num inference steps, I set it to 25. So we get this. We send prompt and 16 frames as we desire for generation, and num inference for steps to our loaded model. And then we get the frames, output frames. So also depending on what they return, this pipe width return, we may need to extract the actual frame that we want. So this is just minor. I get the frames for this example. Let me run this and see if it works or not. Hopefully it would work. Print with frames dot shape. So here I'm also going to print the shape of the frames, just to see what is the resolution of the generated images. One thing that we expect here is 16 because the number of frames are expected to be 16. So let me run this. So again, it's not going to be super slow if we load the model in an efficient way. For generating the videos in 25 steps, it took like less than a minute if it doesn't crash again. But even if it crashes, but in practice, it's going to be less than a minute. So in less than a minute, all right. So, and this is the shape. 16 refers to the number of frames. 256 by 256 was the default that was generated for this video, and 3 is the RGB, the channels. So now we have these video frames, which is great. Now let's visualize the first frame. So we can easily use the image library. So we can write from array feed frames the first frame. So if we print these video frames, let me first print it with frames of 0. So I'm just printing the first frame. Let's see what we see. So it's just a bunch of numbers, which is fine. These are referring to the actual pixels. So now one thing we need to do is typically for it depends on which library you use to visualize. In most cases, they require, sometimes they do a scale, but in most cases, they require the range to be within from 0 to 255. And it's also provided here. So we would do the same and then see if we can actually visualize the first frame of the generated video. With frame 0. So now here we just multiply this by 255 to bring these values to scale them. Right now, they are in the range of 0 to 1. We are scaling them to a range of 0 to 255. And then we do this. And then I also change the type to int. So, so that we go from float to int. So if you run this in a separate cell and print it, you would see the numbers are going to be nice and in between 0 to 255. Now, if I run this, great. So this is the first frame of this generated video. Now, convert frames to MP4. So this part is just some pure software engineering work. So you can use different libraries. I'm going to use what diffusers also offer for these purposes. So they have export to video. And then we can also call this and send all the frames. So what I'm doing here is I'm sending all these video frames that we just visualize the first frame. I'm just sending all of it to this tool. And this export to video just takes care of everything that we did here. It's just not going to do it for a single frame. It's going to do it for the video and export it as a video and save it somewhere and give us the path. So, and then let me print the path as well. So let's see what we would see. Okay, so it was exported to a video and this is the path. Now, let's inspect it. And to inspect it, it's very simple. Again, there are different ways these things can be inspected. It took me a while to figure out the right library. So apparently IPython display, you can import video and then simply do video path. But if you manually go to this location and download this file, you would be able to play the video. This is just a way to visualize the video in the notebook. Okay, so I need to do embed equal true. Hopefully it would work. Okay, so this is the video. If I play it, it's just 1 second because I asked for 16 frames. And it's also not super good or high resolution just because the model we are using, the model ID is like one of those efficient models. But as you change the model, everything else is the same. Just bigger model, more parameters. This would turn out to be more higher quality and also higher resolution. So, but this is actually our video generation. And it was reasonably fast. It was 1 minute, even on this on Google Colab. So, okay, that's video part. We can wrap it up. It's also interesting to try different num frames and inference steps. Also note that we use 25 inference steps. If we increase it to 50, this may turn out probably a bit nicer. But what is important, I mean, the whole purpose of this project and this code is not just to get this video. It's basically to show that in order to generate videos, this is the process. So this is the difficult part, to go from 0 to something like this. In order to go from something like this to something really great, it's just a matter of changing your model. Just change your model to a better, more powerful pre-trained model, or train your own model and just switch that. And the rest is going to be similar. And then suddenly you would see much, much better videos. Okay, so that's it. And then the last part, which is going to overlap with what we saw, but basically it's just going to put together everything we've learned. Here, the purpose is to create a single setup or a single system that can process requests of users and then determine what this request is. Is it going to be satisfied just in a textual way, or some image or video generation is required? In order to do that, we need one additional component. And what we want is an LLM to decide if a given query is just a text query or it's image or video generation model. And so this part we are already very familiar. We can pick some model. I'm going to pick Gemma 3, 1B instruction tuned. And then the rest is just loading the tokenizer, the model, and then, or just a pipeline. So let me copy paste to save time. So just simple stuff. I'm loading the tokenizer of this model, the model itself, the weights, and then some efficiency related thing. And then here I'm creating this pipeline of calling it Gemma LLM, which is a text generation model. Gemma is a text generation model. So here I'm just gonna load it. Let me run this. While it's being run, let's go to the next step. So this part is going to be simple. In this function, it's a helper function. We are going to implement something so it determines. Basically, if the mode is image, it's just a routing function, a simple helper routing function. If the mode is image, it would send this prompt to the loaded image pipe. If the mode is video, it would send it to the loaded video pipe. And if it's a text, it would just takes care of it for now. So let's just narrow it down. The generate media, let's just focus on image and video, not text. So that would be handled somewhere else. So this part is also quite straightforward, and it's just some software engineering code. If mode equal image, return pipe image prompt dot images of 0. This is we already implemented before. Else it is video, or we can check if it's video, but for now, let's assume it's going to be video. Then we can write frames equal pipe bit prompt num frames. I'll keep it small intentionally to keep things fast. Num inference steps 25. And then I want all the frames. Or I can do like this. And then return frames. So this is the generate media. It's just simply deciding which model to call based on the mode. Now, the next thing is LLM generate. This part is taking care of if the request is a text kind of request. So we've seen this before. It's also simple, and 1 or 2 lines of code. We send the request to the model that we that we loaded and instantiated here. It's still loading. It's 2 gigabytes. Hopefully, you're not going to run out of memory. So prompt, then max new tokens equal max new tokens, and then temperature equal temperature. So we have the output here. Oh, and I can ask it to do a use a top P top K. Do not do sample. So basically, it sample from the probabilities, not use a greedy sampling. So that's it. Then I can just return based on the format and what it returns. I have it from before, but it usually requires some inspection. You need to print the output to see what it outputs and then extract the part that you want. So these are just minor things. I have already inspected what output look like, and then I'm just extracting the actual content, which is the response of the Gemma to this prompt. So this should be the implementation of these two helper functions. Let me see if this is complete. Okay, this one seems to be complete. So we have the Gemma LLM model successfully. It's loaded. We have also successfully loaded the video model. We don't have the image model. It crashed, so I'm not gonna run those. But in practice, we would have also that already loaded in memory. So now let me run this function. These are just helper functions, unless I have syntax error. Okay. And now this is the main part. This is the routing part. This is the part where we classify a prompt, whether it's an image or video. So this part is going to be similar to what we saw earlier. I'm going to copy paste my code and then walk over it. Okay, it looks very long, but it's very simple. We create a system prompt, and then in the system prompt, we instruct a model, an LLM, to what to do, what we want. And here we want to classify this prompt into one of the types, whether it's image, video, or text. So here I'm very clearly asking the model you are a routing assistant for a multimodal generation system. Decide whether the user request is a factual or conversational question, an image generation or video generation, and use this format. So this is my system prompt. And then I construct these messages. The role is a system, and then I pass this system prompt I created here. The role for the user, and this is just a prompt that is given as the input of this function. We want to classify this prompt. So the user message as the prompt itself. And the system is just giving the instructions. All right, then the next, we just send a message to the LLM generate, the Gemma model. Oh, we send this message to this LLM generate here to figure out if this request, like the mode of the request. So this LLM generate was just responsible to use this load Gemma and run this prompt. So we are using it here for the purpose of classification. So I send message to LLM generate. I get the response. This is the response to this query, as well as the prompt, as a input prompt. So here we have the prompt. Then we use some regular expression. This is not a big deal, but basically it's just to extract this part and figure out if the output is QA, image, or video. And if there is a match, these are just pure, I'm not going to go over them. The whole purpose of this part is from the response of the generated response from LLM, we figure out if it has this, or this. So this is good. We have this classify prompt function as well. Great. So now the last part is our agent. this is also similar to what we've seen before. It is going to use our helper functions and just call them. So given the user prompt to this multimodal agent, so now this user prompt, it is what you saw here by this user prompt. So the first time that a user enters something in your platform. The user prompt, so the first thing we need to do is we need to first classify it. So we send it to the classify prompt that we implemented. Here we get the decision. If the decision is has a type, we get the type of it. And by default, we set it to Q&A. So if there are some errors or it cannot be parsed, we set it to Q&A. Otherwise, it's going to be the type produced by this LLM Gemma model. And now simply we can just have an if statement. If the kind is Q&A, this is a system prompt. You are a helpful assistant. We form the message with this system and user prompt and send it to the LLM generate again. Otherwise, if it's not Q&A, it's certainly a media generation request. So then we send it to generate media, and generate media would just take care of deciding whether to send it to image or video model. And here we also send the mode, specifying whether this is an image or video. There are better ways probably to implement this. This is just one way. Things can be more cleaner or more modularized. But this is obviously one way that this could be implemented. Now, let me also run this. Great. And now it's time to test it. Here. So I have just 3 different prompts here in a list. The first is what is the capital of Iceland? The second is generate an image of a neon dragon, whatever. And then finally create a short video of a paper plane folding itself. This can be anything. This is just for a demo. In practice, these are coming from users. Now, all I need to do is whenever there is a request like this, I would just send it to the multimodal agent. And under the hood, first, it would be classified, whether it's a Q&A, image, or video. Then it would send it to the corresponding model. So, and then the result would be the actual result. Now, here we print the prompt. And then we say if the result is a string, it means that it wasn't Q&A. So it's just a response in text format. Just present it. Just print it. Otherwise, it's a media. So we need to display it. And if it's image, we just use the display. If it's video, we first export it, save it, and then here we can just show it. For now, I'm going to remove this line just because we don't have image model loaded. Now, let me run this. What we expect as the output is 2 things. One is the response to this, and one is a video about this. And remember, all we are doing is we are just writing our request in a textual format. This whole system, this multimodal agent would figure out what is the nature of the request and which model it should be used for this. So let me run this. Hopefully it's going to run without crashing, so we can conclude it. So what is the capital of Iceland? Okay, this was quite fast because the text model was fast. So it says the capital of Iceland is this place. Yeah, I cannot read it, sorry. And then the video seems to be being generated successfully. So what it's showing is that it was successfully able to figure out that the second request was a video generation request, and it was successfully routed to our loaded video model. And now it's in the denoising iteration for 25 steps. And then let's see what's the video going to look like. All right, that is complete. Probably it's now being saved. Okay, it's showing the prompt, the video path, and the actual video. So yeah, not super good, but just the fact that the whole setup is working, that's the most difficult part. Getting this done is just switching the model to something better. And then the last part is our UI is nothing but just a simple UI. Where we can ask a question here. If it's image, it would be shown here. If it's video, it would have been shown here. So I'm not gonna run it. It's just the same process. It's just the same code cleaned up in this function. So that's how typically these things can be implemented. It's just a simple prototype, but in practice, the core of it is the same. The rest is just some efficiency or cleanup and make sure things are there are fallback mechanism for everything that might happen and those kind of things. So yeah, that's it. I think we can now wrap up our last project. So a couple of logistical stuff I want to go over, and then I'll take questions. So a couple of things. I sent an announcement for end of the course checklist. Please go over them when you get a chance. A couple of things that I want to emphasize. One is that the final project, please make sure to add your capstone project to the shared sheet that we had and we shared. So that's one thing. The second thing is for presentation. If you open this sheet, so there are two columns here, present on November 9th or present on November 30th. Please, if your projects are already ready, present tomorrow. If it's not ready and you're still interested to work more on the projects, you have the option to present it on here. But what is important is that please make sure to fill this and mark this, especially if you want to present tomorrow. Because later today, we would finalize this and then finalize the schedule of tomorrow's demo day. So that's one thing. Please make sure to have, if you want to present tomorrow, please make sure to mark it yes for tomorrow. So that's about the projects. And then the additional thing, it's optional. Our course will officially be concluded tomorrow. And this is completely optional. This is just an extra demo session. So you get more time to work on your projects and spend more time to build something. So it's also going to be recorded. So no push for joining. Only join if you want to present or if you are interested to see the presentations. I encourage you to join, but no push. Next is course survey. We have a course survey. We really care about this and appreciate if you can spend a few minutes filling them. It's going to be really helpful for us. We want to use it to help to improve our course content and the format and everything that we are doing. So we really want to know your opinion. Please prioritize this. GitHub access. So we will make the GitHub private today, and then we'll send invites to you. So once you accept the invite, you would have access to the repo. And if there was any issues, just please write to us. You can DM me or just post it, and then we'll make sure to resend it. Or if you need a different email to be resent and you haven't received for any reason, just let us know. This is going to be made private because I want to also push the solution so you have access to. But I also don't want to, I want to make sure that future cohorts, they would have a good learning experience. So I don't want the solutions to be easily accessible. So that's the reasoning behind it. And then you will have access to the portal and community. And so you will see all the materials. As we change the material or improve them in future, we would also update your course portal. So you would see any changes or any improvements. And then the certificates will be issued tomorrow. Again, if there are questions, concerns, please post them. So that's one thing. The other thing is so there was a lot of good requests throughout the course about like good questions and requests about like different resources for different topics like security, AI eval, RAGs, and so on. So I created a bunch of PDFs, and in each PDF I added some good reading list, which I think can be helpful. So in case you are interested about any of those, you can go and take a look. It is already uploaded in the course platform. It is under, let me think. It is, if you go to the course portal, and you don't need to do this view course, but if you go to the course portal and here under the capstone project files, you would see these additional links. It's a zip, and it has, I think, 24 or 26 PDFs with reading materials, and they're just mostly links. And that's just one thing I wanted to let you know. Demo day, I already talked about. Repo, some folks I saw, they ask about the solutions. I removed the solutions for the reason that I just explained. The solutions are going to be available for you under deep dives. So if you go in your course portal, for any week that you want to see the solution, like project 1 deep dive, project 2, and any week like project 4 deep dive, if you go here and to files, you would see the solution for now. After we make the repo private, I would push the solutions again. So that's about that. I saw some questions whether after the session concludes, they would be able to ask questions or there would be support. So the course would be officially wrapped up tomorrow. By tomorrow, obviously, if any questions you have, please post them. I would certainly make sure to respond as before. After the course concludes, I still encourage everyone to contribute because the whole purpose of our cohort was the community that we have formed and we would continue being part of moving forward. So I encourage anybody to contribute, and this contribution means if you have questions, please ask. If you see questions that you know the answer, please answer. And myself included, when I see questions, and if I try to also prioritize, but it may be a little bit more delayed compared to what you've seen throughout the course. But all of us, I really encourage all of us to share resources, anything that would be helpful for others. So yes, please continue asking your questions whenever there are questions, and please also answer questions. I would also try to answer. That's one thing. And one last thing before we finish is the survey. So I know I talked about the survey, but I just wanted to emphasize, please fill the survey. That's going to be very important for us. And so far, like, you provided a lot of feedback, and we tried to adapt as quickly as we could and improve the course. So there was a lot of value in it. So we'll promise as you give us feedback, I will try to improve. And then that's it. So one last thing is just I wanted to thank you. So I think it was great. Last couple of weeks, I also learned a lot. I was answering lots of questions, and I also learned because for some of those questions, I had to do some research and see what is out there to make sure that my answers are accurate. So there was also a lot of learning for me, and I had a lot of interactions. So thank you, everyone. Thank you for contributing and being part of this. So yeah, that was the last thing. And then I shared all of this because I was not sure if tomorrow folks would, like how many people would join. I encourage anybody to join, like everybody to join. It's going to be very nice demo session. People would share what they're doing. But I shared all these logistical things in case tomorrow you are not able to join. So tomorrow is not going to be anything from my side. It's just going to be different teams or different people presenting. So yeah, I just shared everything. Thank you again, and I'll take questions now. Aiki?
Oh, yes. Hi, Ali. Can you hear me?
Hey. Yes.
Okay, very quick, a few questions. Number one is related to text to image. Is there some package or library on Hugging Face, whatnot, we can call to do safety check of the output?
That's a good question. I don't know, to be honest. I don't know if they are like out of the box, like there's some tools, or as you mentioned, like a model out of the box you can use to ensure the outputs are safe. But the process is kind of the same. So what you need to do if you want to implement, let's say, that setup is you write a new function, and the model that you need to load is a vision language model. So if you search LM Arena, then you go to leaderboard, you would see vision, no vision. So I think I can share where you can find vision language models, but what you need to do is you need to load vision language models. For example, a good candidate is Qwen3VL. VL stands for vision language model. So once you load this, you can pass both input text as well as input images. So you can then pass the generated image, and then you can also send the instruction, which is process this image and let me know if it has certain content or it's wide lens or things like that. So it's just going to be in terms of the format, the implementation is going to be very similar to this. You just need to load a different model and then send both your generated content and the instruction.
Okay, got it. Second question, also text to image. Can you walk us through a simple process on fine-tuning a generated image? So I don't want to have another random.
You mean fine-tuning a model, right?
No, the image, let's say the generated image you have with the building. Let's say you want to change the tall building to be XYZ. How involved it is to ask the same model without training it. I want you to update this particular one you just gave me. So we keep iterating to it.
That's a good question. It depends on the model. If the model is not trained with those kind of instructions, it won't be able to handle those requests. So that's one thing. So for example, if typically when you train an image, text to image model, you train it on pairs of images and their descriptions. Those descriptions are not in a format like edit or make changes, right? It's just the description of the image. If you train a model like that, you cannot, at runtime, at inference time, you cannot send requests like make this building bigger or edit this image or things like that, because it's going to be, so those kind of instructions would have a different distribution from your training data. Now, this is how original text to image models were trained. And later on, they were trained it on also edit instructions. So when they were training these models, it was also being trained on certain examples of input image and an edit instruction. And then the model were responsible to generate the correct, like generate an image with the correct edits to the provided image. If the model is like that, then you can use it, of course. You can always ask it to generate something. If you don't like it, you can send it back, send the image back and ask some follow-up, like provide some follow-up instruction edits. And then the model would just do it. Most state-of-the-art image models these days are having that functionality. So for example, here, if I send something like make some changes, like can you edit this and make the dog smaller and like white, it exactly knows what we are talking about. It would send this image along with this instruction to the underlying model, and then the model would generate a new image conditioned on your instruction and this image. And the reason that it's going to be able to do this is because this is how it's going to be, how it's trained. If it's not trained like that, it won't be able to do it. The model that we loaded here, which we actually couldn't load, but we were supposed to load, that model is not capable of doing that. So if you send an instruction like this, it would not produce your desired outcome.
So how can we tell which model we can load to have this capability from a huge list of models?
Yeah, you just need to go and read their website or project description or paper. That's the simplest way.
Got it. My last question is related to project 5. So I ran into issues of running out of GPU and I refused to purchase. So I just wait till the next day. I noticed that we can purchase like one time for like 99 unit or 100. I have a hard time translating what it means. Like how much runtime do I have with if I pay this amount? Like 100 compute units. What does that equate to?
So in general, I don't know about that particular example, but in general, the way it works is that you either buy physical GPU or you rent GPU from some cloud providers. Rent H100 GPU. So either you go and directly rent it from, let's say, AWS, or there are a bunch of different startups and companies that are offering with some additional features or things like that. You can also buy from those. So I don't know which of these are the best. I'm not really promoting any of these. So I heard about Lambda.ai, and together, I mean, they are big inference engine providers. So you can also ask them what you want. But in practice, for example, you say you want H100 and you want like this many, and then you submit your request or you rent it. And then the rent is typically per hour. So you get charged like 20 hours per hour if you rent one single H100 GPU. As long as you have that GPU, you can run computations on it. So you can load the model on it. You can perform computations on that GPU. You can train models. You can even run inference on big models on that GPU and so on. So that's typically how it works.
Okay. Yeah, the compute units I talk about is specifically from Colab Pro because when I ran out, it asked me to pay. I
I
read about.
see. To be honest, I have never paid with Google Colab, so I don't know how it works. I can search and share with you.
Okay, thank you.
Anyway, I don't think if as long as things are just at a like curiosity phase and you want to experiment something, it might be fine. But in order to develop more like real prototypes or production systems, typically you need to rent a GPU and switch from Colab. So just a side note.
All right, thank you. That's it. Thank you.
Yeah. Ravi?
Hey, Ali, can you hear me?
Yes.
Yeah. Hey, I have two questions. One of them you you answered it already about the solution. So when all said and done, after you make the GitHub for the private, you will have the solution for this assignment, today's assignment too, right?
Sure, yes. I mean, when I change it to private, I would push. But for today's assignment, I think it's already available if you are.
Oh, okay.
I have to check. It should be available. If not, let me check right now. Yes, it's already available.
Okay. Okay. And my second question was about the inference steps, right? The default value you said is 50, right? So how do we start with 50 as a starting point and then test it and iteratively increase it, or how do we set the
Yeah.
value of that?
So typically 50 is a standard, and that's because it was proposed in the DDIM paper, and it's reasonably in terms of error. You have the least drop in the quality. So the good practice is to start from 50, and then you see if it works for you or not, both in terms of quality and speed. If it's too slow, then you can gradually switch to smaller values or switch to models that work better with the smaller inference steps. And that can include consistency models, as I shared. So that's typically the best practice. And if the quality is not good, you may want to increase this number of inference steps and or switch to a different model.
Okay, but if for a given prompt, let's say with a given prompt, I find that 60 is the number that it gives good image, right? Then for the another prompt, it may or may not give the good output, right?
No, that's not typically a worry in practice. If 60 works, it typically works regardless of the prompt. It typically works across. And that's because the model, I mean, if the model can generate good image for a certain prompt at 60, it's very likely that it can generate the same quality images for all different types of prompts.
Okay.
So you typically, I mean, in practice, I've never seen people keep changing it. They fix it. They come up with something that works and then they fix it.
Okay, thanks.
Yeah. Eugen?
Hi, Ali. Can you hear me?
Yes.
Great. I have a question related to the training process in diffusion model. So it's not intuitive to me that the training process starts with a random noise and let the model learn how to denoise it and then output the image. So, I mean, it's amazing to see the results, but can you tell me what's the motivation behind of using this denoising technique?
Sure.
Yeah.
So I would say the best way, like intuitive way, if you want to think about this, is that you want to train a model that if it's given this image, it just produces a slightly less noisy image. This should be doable, right? Because if there are certain signals already in the image, we should be able to train a neural network to figure out how can it make it slightly less noisy. So that's the key idea, like the key intuition for the diffusion process. If we can train a model to make this image with certain obvious patterns that we are seeing, a slightly less noisy, given that we have access to ground truth values, meaning that we have already a correct answer here, which is less noisier version of this. So we already have that. That's the ground truth. Given that we have that ground truth and there are obvious signals present here, if we train a neural network that can goes from this to the ground truth, then this whole thing would work, right? Because that's all we need. At the end of the day, all we need is a model that can just make a noisy image a slightly less noisy. Because then we can put it in a loop. We can keep denoising an image step by step. Does that make more sense now? Or there are certain parts that you think it's confusing?
I think it's just not intuitive to think about this method of, or it's start with a random noise, like we don't see any pattern in it, and then it can generate.
Oh, I see.
Yeah.
So random noise is a good point. So, but what I described, does that make sense? Like when there is a signal in the image.
Yeah, because like you say, where do you see like the face in the image just have some noise, but we still see some pattern in it.
Yes.
Or is it the denoising technique is a common method in research?
Sorry, I think give me 1 second. I'm thinking I think I can find a very good visual which might help. Okay, so I think this is the visual I was looking for. Before you see this, coming back here. When the signal is clear, we are good. When it's not clear, now the question is how can it go from random, like pure noise? And the answer to this is that, and I assume we are talking about pure image generation, not text to image generation. Because when there is a text to image generation problem, even when the input initial noise is random, like pure random noise, the text still can influence because the model was trained on such pairs as well. The model occasionally was trained on a pure noise and the textual description of, let's say, I want like a lady in this format. And then the diffusion model has seen that for this particular description, even when there is a random noise, this is the right way to move toward the right direction to denoise it. This is for text to image. When it's pure image generation, the way that the model figured this out when the input is random noise is it's also trained with those kind of examples as well. So during the training, we do not always send these kind of images with some signals. We occasionally send pure noise and then shows this with some signals. So the model would learn that whenever the input is a pure noise, how can it, like in what direction it should subtract noises iteratively so that at some point it becomes a clear image. Again, this is pure image generation. In text to image generation, things are easier because this whole generation is also being influenced by the text. And during training, the model has seen lots of different text, even when the input is pure noise. So if you think of this, the model learns this trajectory, if you think of it. So this trajectory is what the model is learning. So when you start from a random noise, you are starting from somewhere here. The model already has some ideas how to move, in what direction to move back so that it leads to a good, clear image. So yeah, I hope that clear things up a little bit.
Yeah, it helps. Just one question. I don't know if it makes sense, but is it related to some space that the model wanted to learn the relationship between the text and then the image?
Yes, that's
Like
exactly what happens. Yeah. Basically, the
Okay.
model is learning a conditional distribution given the noisy image as well as the text. So the model is learning to go from these two to a less noisy image. So when you train on lots of data, like billions of examples, the model would eventually learn that even when the input is just pure noise, but for a certain description or prompt, this is the right way to move to subtract noise.
Okay, thank you.
Yeah. Tanvir. Hey, Tanvir. Please go ahead. Tanvir, we cannot hear. Oh yeah.
Yeah,
Go
can you
ahead.
hear me now? Thank you.
Yes.
Yeah, actually, I also had, I think on Wednesday, I had asked about noise. So I mean, you helped me, but still the question is, looks like diffusion model is based on noise. So the question comes to my mind, can't we train the model without noise, just giving, so I think you explained, I mean, still I am trying to comprehend. I'll continue, but my question is, around, there is Hugging Face, Olama, LangChain, PyTorch. I have some understanding on when to use what. If you can just talk briefly on that.
Sure. I think that the first question that determines is whether you are dealing or you want to deal with text or image video generation. If it's text, the libraries that you typically require is Hugging Face, let's say for development, like transformers and what we saw in the first 4 weeks, or some tools like Olama that are built as inference engines. So you can load pre-trained LLMs. If your use case is to deal with images and videos, then you may no longer need those. You need some other set of tools or libraries. And one example we saw today was Hugging Face diffusers. So it's just a different library, which is hosting open weight models, and then you can load them and just run them or fine tune them. So that's basically the difference between all those tools and libraries. Like, for example, LangChain I think LangChain, if you search LangChain, they are saying that LangChain provides the engineering platform and open source framework developers use to build, test, and deploy reliable AI agents. So it's more focused on AI agents. It's going to give you all the tools to build agents. It's not going to give you tools for training or building, let's say, text-to-video models. And same for inference engines. Like Together AI, I think they do have lots of image models. Yeah, so they have lots of different vision language models, like text-to-image models, and so on. Text-to-image models. So it all depends on figuring out what you are building. If you're building agent, there are certain tools. If you are building text-based models, there's certain tools that you can use. If it's more on image or video generation, then you most likely need inference tools that are designed for or hosting those models.
Okay, thank you.
Yeah. Sonia?
Yes, hi Ali. So first, thank you so much for the class, and thank you to all the cohort participants. We all helped out each other, and I really liked that, and I really benefited from it. So thanks to everybody. And again, to start, like there's a diffusion question, that Ian was earlier asking, and I was hearing the explanation, but like see here during training, like you said, there is billions of data is given. So from this initial random noise during the inference time, it can go in all those billions of directions, right? There are it's like it can have so many permutations and combinations, right? And
Exactly.
then
Yes.
right, so just randomly, or it decides to choose some permutation and combination. Is that right?
That's exactly right. So that's why in ChatGPT, okay, so I think my laptop is getting very, so let me close these tabs and let me show you. Okay. Your understanding is exactly accurate, right? Just because of this process, when you start for a random noise, even with some text input like a dog, you end up with different outputs.
Here we don't have any text. I mean, when text is
Oh,
there,
when
then
there
I
is
know.
when there is no text, it's even worse because now there is no control really over generation, right? And that's how the very early version of image generation models were working, and that was the problem. I mean, it was nice in a sense that you could generate things, but then you had zero control over it. You start from some random noise. Sometimes it give you a dog. Sometimes it give you a office, or sometimes it give you a phone, like all these different sorts of, depending on the training data. It's trying to average out the training data. So if there are lots of, let's say, car examples in the training data, in many cases you would end up to a car with a car if you start from randomness. So when it's image generation, it's always very random. You have no control. When it's text to video, it's less random because now you can influence. At least you can say that, hey, I want dogs, right? But you still have no control. So for example, to better understand, here I asked ChatGPT to generate an image of a dog. It generated this for me. And then it's giving two examples. What it means, well, I mean, what is happening under the hood, it's just starting from two different noises. It's just starting from two different noises with the exact same query that I have here. And then each time it's run, basically it runs the model two times. So the model generates two different images with the exact same prompt. The reason for that is just because they start from two different noises. And if I ask it one more time here, it's almost impossible. I get this. The only way that I can get this is, as a developer, you set all your random seeds to something fixed, so that next time you make sure that even the random noise that you start from is exactly the same random noise. And you also make sure that there is no stochasticity in your sampling process. That's the only way you can get the exact same thing. In practice, it's not the case. Here, OpenAI is not giving you access to those kind of things. And it's very likely that it's not fixed. So it's random. So now here, if you see, it's a different dog.
Okay, so yeah, I mean, I get that okay, when there is this text prompt is given, it is a little bit guided, there is some guidance. But in that diffusion model here, it can be like any of those permutation combinations of that billions of it. It can be any of it, right? Is that right?
Yeah. Yes, that's right.
Right way to understand?
Yeah.
Okay.
Yeah.
Okay. All right. So that helps. And then if you could please go back to your solution, and that we did today. And in that, yeah, like for example, here, couple of times, you said that Hugging Face does this. Like for example, this number inference steps is a parameter given by Hugging Face. So now here we are using the models we're picking a model out of all that is hosted by Hugging Face. So is it then these, like here you said, and I mean, for example, this inference steps, and then in the loop also you said, Hugging Face is doing it. So is it then is it that model is just something that is downloaded, and beyond that, Hugging Face is providing this interface to control with all this, or it is doing some things,
Yes.
like these
Yeah, exactly.
parameters or whatever.
Exactly. This is a class, like pipeline class, let's say, right? You can write image generation pipeline. You can think of the Hugging Face, what is providing to you something like this. This is a very simplified version. There is a class, right? This is just a Python class. And then you can specify which model you want. It would load the model here, load model. It does self.model under the hood, whatever the code is required to load the model. It would give you the a call, which is where you just pass this prompt, self prompt, and then it generates image for you. And then to generate image, there is a for loop for I in range, num, inference steps, do something like denoise, let's say. And denoising is very simple. You just need to pass denoised image self.model. You send the prompt, let's say. You also send the image, the prev image. Or we can, yeah, so we can prev image. You send the previous image and prompt, you get the denoised, and this whole thing is in a loop. And then at the very end, you would end up with a clear image, so you return it. This is roughly a very simplified version of the implementation you can think of. It's just a class, so you can load the model, you can specify the num inference steps here, or you can set some default here, and then you can adjust it here if it's provided. You can just play with this, but this is the way that it's implemented.
So like model can be anything, but this num inference steps, for example, is a parameter that Hugging Face has in interacting in the implementation or whatever
Yes.
manifestation of that model.
Exactly. Yeah. And if you switch to a different tool, they may call it differently. But then you need to always look for something like this. Either it's num inference steps or num steps or whatever. You need to look for this always.
So model is like the agent was calling all these tools. So that similar way, Hugging Face is calling this model, but then it has all these, for example, parameters or whatever. It is controlling everything, kind of. That seems to me.
Yeah.
Okay. And there was this code. If you can go where. This prompt code of classify, I think classify prompt code. Yeah, here, like this system prompt and messages we are writing at two different places. I didn't understand why is that.
System and prompt?
Yeah, this whole system prompt, it is written in two different places. If I got it right, or I'm not sure if I got it right.
It's only here, right?
Oh, is it only here? It's not at another place?
I mean,
Yeah,
so,
like see here also
yeah.
you are giving. Why is that?
Because we are basically solving different problems here. I mean, here our purpose is that we already know that it's a Q&A kind of request. So we use the LLM to answer this question, and then the instruction is just simply you are a helpful assistant. Here, our goal is different. In this function, our goal is to classify prompt. So we set a different instructions when we are sending it to the model.
So then, okay, so this prompt is for classification and for classification purpose, this system prompt, and
And this
other
is
one.
this is just there. I mean, it's not even necessary. It's in this case, it's just you are a simple assistant. But depending on what you are implementing and what your LLM want to behave, you can figure out the right system. Here, the way we want this to behave is just to answer the like Q&A question provided by the user. So we just set an instruction like this.
So we don't need this kind of prompt for this generate media?
No, because for generate video, the way it's trained on pairs of descriptions or captions and images or videos. So all they expect as the input is just an image, is just a caption or description. It's just different ways that they are being trained.
This whole generate media, both for image and video, we don't need a prompt the way we put it for text. That's what
That
I'm
is right.
asking.
Yes. We don't need system prompt or things like that. We just, the way it's trained is on pairs of images and descriptions, right? So at inference time, you also need to follow that. You cannot provide like a system prompt. The model is not expecting that. It's not trained to deal with that.
I see. Okay. All right. I think, and I think that 50 was the default. 50 is a default number of steps, and we can also increase it, right? If it must be in the documentation.
You can increase it, yeah. You can go all the way up to, I think, I don't know what is the max. But as you increase, over time, you won't see a lot of quality improvement. But as you increase, you would see the slowness. So the speed would hurt. So it also depends on the model. Some models are, the performance is not going to be improved at a certain point. But yes, you can theoretically go above 50.
Okay. And this survey that you're saying, do it by tomorrow end or by
whenever whenever you find the time. There is no pressure to do it immediately, but what is important is at some point you share it with us.
Okay, great. And then all these notebook files, when you will give us this private access to GitHub, will they be in that GitHub or no?
It is the same. It's the same repo. We just would make it private and then send you invites. So you would receive an email. If you accept the invite, you would have access to the same repo.
I see. Okay.
Yeah.
All
and
right.
if you run into any issues, you can just post it. I mean, the channels would be there still. Yeah.
Okay. Got it. Yeah. Got it. Yeah, and just want to share that I actually had to purchase that $9.99. I ended up purchasing because it was like constantly crashing, and I was I just did the minimal one, just sharing. Okay.
Yeah.
Thank you so much, Ali, and to everybody also. Thank you. Appreciate it. Really appreciate it.
Yeah. Thanks, Sonia. So while I'm going to go to the next question, I'm going to run this again to see if it's going to run. Oh, actually, it's disconnected. Okay, then there is no hope. Okay, go ahead, Viva.
Thank you, Ali. I was waiting for my turn. So I have a two-part question. I will start with the second question. Since we are at the end of this entire exercise, my question was, from my perspective, we learned too much that's taking time for me to consume and internalize. What is expected in the industry after we are done with this one? And the takeaway from my side should be that I should earn so much understanding and experience so that I can go and counter the interviews. So, what level of questions and expectations are expected from the interviewers? And what can we, can we use this as a stepping stone? So, whatever we are learning here, is this good enough to start for interviewing, or
Yeah.
should we have more experience?
Sure, I can share my thoughts. Okay, I think
Great.
there are more hopes that it's going to work this time. Sorry, I can share my thoughts. The first thing I want to share is that it really depends on the company and that role, right? So sometimes the smaller companies have more unique way to interview, so they would structure everything about that, and also they would structure it around their need, especially if they're smaller teams, because sometimes they have a very particular need, let's say on implementing a kernel or a CUDA kernel for a certain thing. So in those cases, you cannot really generalize. In those cases, the questions most likely going to be around very low level, like GPU understanding, like GPU characteristics, how to implement GPU kernels, and so on. So that's about that. But in general, what you can expect from AI interviews is that there is this component of machine learning system design, or they may call it something different, like AI system design. Based on what you learned, especially from the guided learnings, you should be able to, you basically should know, like theoretically, you should know everything that they may ask. Again, it also depends on their focus. If they're focused on a Gen AI role, then there would be more questions around Gen AI. If for example, a lot of roles by Meta are for their search and recommendation teams. So there would be less questions on Gen AI. There would be more questions on search and recommendation. Actually, a lot of messages that I receive from people that, like, the machine learning book helped them to get a role at Meta. Like, a lot of them are at Meta. Like, a lot of people that say good things about the machine learning book, machine learning system design interview book, they are from Meta. And that's because Meta asks a lot of questions about search and recommendation systems, if that's the role. And other companies which ask about Gen AI, then Gen AI topics are become more important. Long story short, what I want to say is that if the interview is typical, if it's from a big company, it's a typical role, there is not a specific need, it's not like super senior. If it's typical, you should know everything that they expect, assuming that you know all the concepts that were covered in the guided learnings. Now, if there are more emphasis or focus on a certain topic, you may still need to go and read those papers or additional links or resources that I shared, or even you may need to go beyond that. But you should know the concepts and foundations of most of those interviews, I would say, for machine learning system design.
Got it. One follow-up on the same one, right? So, do they expect us? Is it more like a system design interview, or do we need to actually build something over there, right there, during interviews?
System design is more default these days. So almost all companies that I'm aware of, they do ask some sort of machine learning system design. In most cases, it's theory. Occasionally, they may also need to implement some coding. If they want you to implement something, it's not typically a big project. The projects that you've seen are more like to better understand the concepts, or you build some prototypes. This kind of coding is less useful in actual coding interviews, like ML coding interviews. In ML coding interviews, they typically ask something like the first project, if you go and review it, that's more aligned with what you would typically see in ML coding interviews. It's just simpler questions. They just ask you to implement something very simple or implement attention or something like that. It remains at that level in most cases.
Got it. My first question will be towards, which is generative AI towards a video generation from the frame. So let's say we need to build a system where we only know the starting of the video, which is a few frames or short clip, and end of the video, which is either a clip or a few image. So does the diffusion model is suitable to fill in all the gaps between these two frames to complete it?
Yes. You just need to train. You just need to train the model that way. And it's a typical use case. If you go to Runway ML, they offer a lot of these fancy kind of features. But this is under the hood how they are training. It's just very simple. It's just different way of training. If they want to offer to their customer a feature that you can provide first few frames and it would just complete it, they need to also train the model that way. They need to train it. They need to train it by providing a few frames and then noise the remaining frames and ask the model to predict the like the noisy frames. This is how it works.
Got it. Thank you.
Text. Yeah. Video. Video continuation. Continuation. Oh, extend video. Yeah, Runway, for example, has this extend video. So there is this paper, if just continuing that, from Meta, EMU 3.5. No, EMU 3, Meta. If you read this, this is a good paper to read to understand how you can train. You can go to understand how to go beyond pure text to video and how to train the model so it can do other things as well, including continuing the videos, even in painting, out painting, and all those kind of things. Sorry, this is not the paper. You have to search for EMU3 video. This one. This is a good place to understand how you can train your model with more capabilities.
Got it. So this vision model, right?
Oh.
Recently, all these video generation model, are these? Let me frame my question, right? So we have a transformer model, and we previously had the CNN and GNN models, right? So to understand the image and generating frames and everything. So in recent times, all the newer models that are capable of generating the entire video footage, are they a combination of transformer, always a transformer, or there is a separate thing coming out that is replacing the transformer in order to better understand the token generation?
No. From as far as I know, it's all transformer based, and it's pure transformer. I have seen in most cases companies completely drop any kind of convolution layers. So it's just pure decoder only transformer, very similar to text generation.
So it's pure transformer model now.
Yes.
Oh, awesome. Thank you.
Of course. Prasad.
Hi, Ali. Good evening. Can you hear me?
Yes, I can.
Thank you. First of all, thank you so much. This past few weeks had been really amazing. Journey-wise, learning from you and also from the cohort participants. I learned a lot in the Zoom chat also. So thank you so much. I try to keep it short. I have so many questions. I have one question about the exercise 2.4, if I am right.
Sorry, I lost you for a second. You have one question about what?
2.4. Can you hear me now?
I can hear you. I just lost you for a second.
Okay, sorry about that. Then yeah, in the one of the video, text to image generation, we have to switch move the latent tensors, right, to CPU immediately after the step. Like when they are doing the processing, every step you have to move to the tensors to the CPU to avoid the GPU memory buildup, right? But why doesn't the diffuser library does this automatically? Like why should we have to do? Because I'm trying to scale it to production, let's say. How will I keep, like, is it advisable to do it manually every time, or the library should take care of it? Like if the GPU is not available, switch to CPU. Is that a valid question, first of all?
It is, no, of course, it is a good question, and it makes me also thinking about it. Obviously, there are some reasons, and I think usually these things are not provided if there is not a consensus yet. What is the best way to do it? This is the best answer that I can provide. So I think if it's not provided here, it is something that different people, different companies, different teams might want to do it differently, depending on their infrastructure or their algorithm. And then they would do it anyway on their own. So it's not something that is going to be super helpful or it's not going to be something that the library or the diffuser, let's say, can abstract it away. This could explain it in general, and my answer was more generic, not for a particular thing. Yeah.
Is that something to do with the, what do you say, security related issues? Maybe like because it's a hardware you're trying to permission.
I don't think
Mhm.
it's going to be security related. I think it's just something because at the end of the day, for most production systems that you want to build, at the end of the day, you have companies do a lot of these things. They do not even rely on diffusion pipeline. I mean, I'm pretty sure, for example, OpenAI is not using diffusion pipeline. Not pretty sure, but I'm 99% sure that they're not using diffusion pipeline. They are implementing their own. They are having their own model. They train their own model, and then they figure out like the best, most efficient way to move computations across their accelerators. That's how it's being done in practice, in production by big companies. So it's not going to really be useful if some of these tools provide those kind of functionalities.
I see. Thank you. So moving on to the next question, I will try to probably rush you, sorry, because I know others have to ask as well. Thank you. For the latent representation, so I tried two models. I saw one discrepancy. I don't know if industry is going to standardize this or not. You may please share your perspective. So what happens is when you are decoding the latents to this images, right? I think the PIL images to visualize them, right? So I think some of the models return, say it's like a NumPy array, and some are returning as a PIL images. Like, so why is the discrepancy between these formats? Why isn't it standardized?
I mean, it's always been there. This is something just out of our hands. I know there are lots of different libraries to work with images and like perform like do image manipulation and all those things. They all have different assumptions when they're implemented. So I think it's there and it's going to be there for longer. Even NumPy and PyTorch is supposed to be very, very similar to NumPy, but still there are libraries and similar namings with different functionalities. So I think it's just unavoidable. As the software is being changed or developed or evolved, there would be certain parts that divergence happens.
Yeah, completely agree. And my last question is mostly about, I know maybe it is an odd question, but I work in this some like regulated industries, GDPR, EU Data Act, etc. So for example, a use case is the pharmaceutical industry. And now you want to train these models for your specific brand. And when they generate these images, you need to make sure that it is brand conscious. How do you do this in the model? Is it more like prompt engineering, or is it like how do you train this?
To
Particular
make sure I understand your question. So your question is if there is a use case where you want to fine-tune an image model or train an image model that generate a certain images, like with a logo or something like that. What is the right way to do that, right?
Exactly. I think it's more about like the brand consciousness and also related to compliance, etc. Can we train it? Is it part of prompt engineering, or how does it happen? Like fine tuning, sorry, not prompt engineering.
So if you want your model to generate certain things, let's say you have a company and you want everything to be influenced around your logo, for instance. The right way is to make sure that your training data is like that. So you can always train your model on big image data. And then after that, you can fine tune it on a small set of images with a particular characteristic that you look for. It can be logos, it can be anything. So if you fine tune your model on that data, the model would very likely generate those kind of images. So there was this work, Google Dream Booth. So they train a model on, let's say, the images of this dog only. And then the model is able to generate this dog in different scenes. So now you can replace this dog with anything that you want, and then you can customize a model to your need. In terms of compliance, it can be also, you can think of it the opposite. You may want to train a model that, for instance, do not generate any logos or IP related things. It's the same story. You need to make sure that you don't have such examples in your training data. So it all goes back to your training data.
I see. And is that expensive as compared to like because fine tuning is an expensive process?
No, it is very, very like it's very practical for even for very small companies. It typically, for example, this Dream Booth, you can easily start from a really good text-to-image model, diffusion model. You apply this technique on your like 20 examples of a certain image, and then train it for like 20 minutes or something. So it's just one day of work. And in general, to customize model, it's super fast and it requires less GPUs as long as your data is high quality.
I see. Gotcha. Thank you so much, Ali. I appreciate your questions. And
Yeah.
thank you so much.
Thanks. Yeah, thanks. The next question is, next hand is Prasad.
Hi, Ali. A quick
Hey.
question. You mentioned you uploaded some documents, right? GIF file. Can you show me where is how to access that? Another one is you also said there is some digital books you're putting into the portal. I want to see where I can access those digital books.
Sure. So your first question is about the reading materials that I mentioned I've created.
Right.
Sure. So that's in your course portal. And the last, if you go to the last capstone project files, here is the zip file. If you unzip it, you would see 20 something PDFs with different topics and links.
Okay.
Yeah. And for the books, I think there was an announcement. I can please post your question. I can share the thread in the announcement, so you can just follow that.
Okay. In the thread you said, okay.
Yeah. Just post your question. I would share a thread with the instructions.
Okay, cool.
Gaurav?
Hey Ali, thanks
Hey.
for this lesson. Yeah, I have one question after this text to image generation. So once we generate the image, how we can evaluate those? Like basically, when whatever the image being generated. So okay. So basically, is this the FID one is the one that we can use in production?
Yes, for evaluation of image generations, there are typically three things you want to evaluate. One is quality, one is diversity, and one is image text alignment. Quality is obvious, like what you want to measure. Basically, you want to make sure that the quality of your generated content is good. And FID is a very typical metric that is being used. Even in most recent image generation papers, you see they report their numbers on FID. And same for diversity. Even FID can also measure the diversity to some extent. For text alignment, you want your images to also adhere to the prompt that was provided. So for example, when you enter like an image of a dog, you don't want to get an image of a cat. So you want to measure that alignment. And that's typically done by Clip score. It's a very common practice. Clip is a model that has a shared embedding space. So it's simply, when you pass a prompt and an image, it would pass the image to image encoder, prompt to the text encoder, and since it's in the shared embedding space, it can simply measure the distance. Ideally, the distance should be very low if there is a high alignment between text and image. So this is the typical metric for image text alignment. Thanks for the question. Cheshta?
Hi, Ali. Thank you for the session and thank you for everybody for asking questions that really help. I had a question about something that I saw in one of the Adobe programs. I'm not sure if it was Illustrator or Photoshop. So what they showed me was that they made an image, and after a while, it turned into a 3D model. And I was not able to understand. It seemed like generative AI, but that's not an image anymore. It has turned into a 3D model. And it's not even a video. So I was trying to understand, is it something proprietary, or do we have open models that do this thing?
Sure. Basically, irrespective of Adobe, I'm not going to talk about Adobe, but there is this topic of text to 3D, very similar to text to image and text to video. So you enter text, you get 3D outputs. And we have also image to 3D models. Like it's just different way to be trained. So the input is it's all about what is the input, what is the output. These models, the input is text, the output is going to be a 3D asset. And a good example is OpenAI's model. So if you go here, you can take a look at this paper. It's basically a text to 3D model. And it's just, most likely it's just a diffusion model. I mean, I know that the best models out there are diffusion models. This is probably a diffusion model. This is now quite old now, but it should be also diffusion based. But regardless of that, this is text to 3D. And you can search and take a look at this. What is text to 3D? Hugging Face, it's probably giving a good explanation. But at its core, it's not different. It's just a diffusion model. And all the main difference is that the data is going to be different. Input text, output 3D. And for 3D, we obviously need a way to represent them, or tokenizer. That's the main difference. And you can also search image to 3D. And there are also some models for image to 3D models. Again, Hugging Face have a page for that. And then if you go there, you would probably see also lots of different models. This is more common path to go from image to 3D. So in practice, this works better. So people typically build a pipeline where you go from text to image and then from image to 3D. And then you can see a bunch of models here.
Thank you so much. Just one more question, and it might not be a good question. What I noticed is when there are developments in a field, usually there would be some competitions, and everybody tries to, solve some kind of problem. When it comes to AI right now, are there any competitions that are, something you would like to follow to develop your understanding of, okay, this is where people are trying to focus a lot to work on the next breakthrough?
You mean like coding competitions, right? Not the competitions between, you're not referring to like companies competing with each other.
Not companies, just
Okay.
coding competitions that work on a specific type of
Sure.
problem.
I can check. I used to participate a lot when I was younger in coding competitions, like in, like data structure and those kind of things. So I'm pretty aware of those. Unfortunately, I didn't participate much on AI competitions. I don't think even if it exists or if it's how big they are. I can search. If I find something, I can share. I know not Hugging Face, okay, I now even don't remember the name of that. I would share, Kaggle, thanks, I saw it in the comment. So Kaggle used to have some interesting competitions for vision, and then perhaps it's very likely that they've switched to AI these days. So you may also want to take a look at those competitions here. So yeah, they have different competitions here. So yeah, I just don't know how relevant they can be. It depends also on the purpose of people. I mean, I'm not sure how relevant they would be when you want to build something or create or prototype some idea. Because these can be too focused like on something very specific. So, but yeah, you can take a look at this.
Okay, thank you so much.
Yeah, thanks. Sonia?
Yeah, I think Craig was also before me, but okay, I'll go ahead. I'll be quick. So I was asking Ali that you mentioned about this debugging. Like in the current assignment, it was crashing, and I was again and again asking ChatGPT and trying to understand. And so I really felt a need to be able to put breakpoints and debug and understand better at this session in the 5. So then you answered my question on the chat. But so are you saying that in the workplace we do not use Colab or Jupyter Lab? We use like developers or are you and anybody writing code is using this VS Code and Cursor so that they can debug and maybe they are more robust?
Well, Colab, it's almost always no. If you are in a company, and there are many reasons, because companies are dealing with codes, they don't want those to be shared somewhere online on the cloud or things like that. I mean, there might be some, I mean, I'm sure Colab is also offering certain things for enterprises. I don't know. But in practice, there are also limitations with Colab. So in practice, people in companies are using an IDE and the company's infrastructure. Google had their own IDE when I was there. And it's similar to VS Code, it's just a different IDE, and it's really great. So people used to code there. And then other companies, they pick some IDEs. I mean, VS Code and Cursor are good. I mean, Cursor is just a clone of VS Code. So I would say VS Code is generally very good to start coding. And then within VS Code, still, in many cases, when you are experimenting or prototyping, you use Jupyter Notebook. So that's a different story. Jupyter Notebook is good for prototypes and quick experiments. But everything is typically within, like the IDE is something like VS Code.
Okay, and so is that this cursor, there is a cursor product also where you do whatever vibe coding or something. Is it the same cursor or different?
It is the same cursor. So the cursor is a clone of VS Code, but it's like a wrapper on top of that. So they also offer like agentic services with some subscriptions. That doesn't necessarily mean that you have to subscribe or buy it. You can just use the cursor IDE and work with it. I mean, just there is no point. I mean, because it's just a clone of VS Code. If people that typically use cursor are also interested in the vibe coding aspect of it, so they have also they use their completion services, autocomplete services. But yeah, that's the same company.
Oh, I see, got it. And like somebody was asking about evaluations. So like, and I know you went over all kinds of evaluations for everything. So when a company is developing a product, there is, say, for all three modes, text, image, video, is an evaluator also implemented to see how accurate the output is?
Yes, there is a lot of evaluations going on when they're building the systems. One is like offline evaluation. Before they deploy, they make sure that every component is good enough and meet constraints, both the image model, video model, text model, and even the routing mechanism, like where we classify the prompt. So all those should be independently evaluated and ensure that they work good enough. And then also the safety evaluation and all those things happen to make sure that the outputs are also safe. And after that, the models are being deployed. But even after deployment, there is also continuous monitoring and evaluation. So then we monitor a lot of things like how fast the generations are happening, like requests when there is a drop or when something is unusual. We try to figure out what is wrong or what went wrong. And same for failures. We look into failures in production and see what is causing them. So the evaluation is just a continuous process. It starts from the very beginning before even deployment all the way to the entire deployment and even after deployment process of deploying features.
Okay, got it. Yeah, that's all. Thank you again very much. Appreciate it.
Yeah, sure. Thanks. Craig?
Hello.
Hey.
Thank you for the course. The curriculum and all the reading material was excellent. I took a class in AI and data science at the beginning of 2024, and like all the material in this course is like new. So it's like the field is growing very fast. So I appreciate all the work that you did putting this course together. I got a lot out of it, and best wish to you in teaching future cohorts. I encourage you to keep teaching. You're a very good teacher.
Thank you so much. Thanks for the kind words. Also, thanks for the PRs. I still know that there are pending PRs. I'm just waiting for the right time to merge them. So thanks.
No problem. So the question that I have is not so much technical, but in one of the other questions you answered, you mentioned like meta, and how they interview for ML positions. But at the same time, like a few weeks ago, Meta laid off like 600 people in their AI division. So I mean, as someone who is working and, needs to keep working for the next 10 years or so because I'm not, financially set where I can do that. Like, what is your recommendation for us to sort of adapt and future-proof our careers, in the next 5, 10 years, or even 1 or 2 years? Because like I'm very concerned that the direction in which companies are moving, I mean, they're moving very fast. They're laying off people. They're saying, oh, we're trying to get more efficient. We need to spend more money on GPUs or whatever excuse they're giving. So that's fine. But like as workers, as civilians, what is your opinion or recommendation for us to future-proof our careers and honestly survive in this age of
Sure.
AI, so that we're not going on the dole to survive?
Yeah. Sure. That's a great point. And to be honest, I'm also, it's the first time I'm seeing these kind of rapid changes and AI. So it's also new for me. I mean, I don't want to say something that turned out to be wrong, 2 years or 5 years from now. I think my honest answer would be, I don't know, because I don't know how it's going to evolve. I mean, at some point you may think that, okay, if it's going to be about AI, then maybe I adapt to AI and learn AI more and make sure that, I'll be well prepared and make sure that I can be a good AI engineer or researcher. And that could be one strategy. It's probably going to be safer compared to some other expertise, which can be automated by AI. So that can be a short-term strategy, but I think longer term, probably it's going to be more complicated than that. And I have no idea what's going to work, what's not going to work. I think we know what the strategy should be. The strategy should be to learn something that is not easy to be replaced. We just don't know what AI would end up replacing by when. So that's the answer. We don't know. And since we don't know that, it becomes difficult to figure out the right strategy. So short answer, I don't know. These are good questions. I just shared what came to my mind, but beyond that, I have no strong opinion. Yeah, I'm sorry, Craig. Yeah, it's hard to anticipate many of these things. I typically see a lot of people like say things like, in 2 years, this would be like that. In 5 years, it's going to be like that. But a lot of those things turn out to be not accurate. So the best way is just to adapt short term and see how can we adapt and learn something that is more relevant in near future for companies or for the carrier, and just follow that. So that's one way. I mean, the other way to think about this is just also passion is important. I mean, some people may care more about doing something that they're passionate about, and less focus on the actual career progress. So, and in those cases, the strategy is simple. I mean, just do what you like and what you are passionate about and just keep doing it. So yeah, that's really all I can share. All right, so I think we also went through all the questions. I want to thank you, all of you again. I would still see you tomorrow and in the other demo session as well. But yeah, thanks again. Thanks. It was awesome to spend time and going through all of these and going through all the questions. Please keep posting questions and answering questions on the course portal. Yep. Thank you so much. Bye.